All right, this is Geometry A, Unit 6, Lesson 6, Triangle Proofs. This lesson concentrates on proving two theorems. The first theorem it's going to prove is that the angles of a triangle add to 180 degrees. We're going to address that in this video. In another video, we're going to address the isosceles triangle theorem, which says that the base angles of an isosceles triangle are congruent. Right, so let's do the triangle angle sum theorem first. The angles of a triangle add to 180 degrees. So if I were to draw any triangle, any generic triangle here, let's say A, B, and C, like so. If I were to draw any generic triangle, that the interior angles would add up to 180 degrees. Okay, so 180 degrees. And let's walk through this proof. The first proof involves drawing an auxiliary line. An auxiliary line is a line added to the proof to make the proof possible. What I'm going to do is I'm going to draw a line through C, through the third vertex here, that is parallel to AB. So let's call this line L. So I'm going to draw a line L. Parallel to AB. So let's indicate such. We use arrows to indicate these are parallel. Okay? And we're going to attempt to prove that angle 1, 2, and 3 add to 180 degrees. But I'm going to label these angles 4 and 5. Okay? And I'm going to add measures of angles 4 plus the measure of angle 3 plus the measure of angle 5 is 180 degrees. By the definition of a straight angle. Okay? Because these three angles together make a straight angle, and the straight angle measures 180 degrees. Okay? Now a little bit of substitution. Measure angle 4 equals the measure of angle 2. And the measure of angle 5 equals the measure, the measure of angle 4 equals the measure of angle 1. And the measure of angle 5 equals the measure of angle 2. Look at what we've got going on here. Let's bring in some colors. The measure of angle 4 equals the measure of angle 1. Okay, we've talked about this in a previous lesson here. When you've got two parallels crossed by a transversal, these two angles are called alternate interior angles. And alternate interior angles are congruent. So the measure of angle 4 equals the measure of angle 1, and the measure of angle 5 equals the measure of angle 2 by the alternate interior angle theorem. Alternate interior angle theorem. Okay? And that means I can substitute. 4 is the same as 1. So up here, I'm going to change 4 into a 1. And 5 is the same as 2. So up here, I'm going to change 5 into 2. We call that substitution. So the measure of angle 4 becomes the measure of angle 1 plus the measure of angle 3. The measure of angle 5 becomes the measure of angle 2. Okay? Therefore, the measure of angle 1 plus the measure of angle 3 plus the measure of angle 2 equals 180 by substitution. Okay, so that's the proof. So it amounts to alternate using the alternate interior angle theorem and the definition of a straight angle being 180 degrees and direct substitution. Okay, let's go ahead and demonstrate the other way to prove the same theorem here. There's another way presented. There are actually dozens of ways to prove this. But let's say we've got some triangle again. Okay. And this time I'm going to draw my auxiliary lines a little differently here. I'm going to extend one of the sides. And then I'm also going to draw another auxiliary line that is parallel to the opposite side of the triangle. So let's call this line L. Line L is parallel to AB. Okay. And again, let's number the angles. 1, 2, 3. And I'm going to number these 4 and 5. Okay, see if you can figure this out. If you want to pause the video and see if you can figure out how this is going to work. Okay, so we know the measure of angles 3 plus 4 plus 5 is 180 degrees. By the definition of straight angle. Okay. We know the measure of angle 4 equals the measure of angle 1. See if you can come up with a rule. Why is 4 the same as 1? 4 is the same as 1 because they're formed by parallels and alternate interior angles. So by the alternate interior angle theorem. And I'm going to use abbreviations just to shorten this here. Alternate interior angle theorem. Okay. Likewise, angle 2, the measure of angle 2 equals the measure of angle 5. See if you can come up with the reason why. Let's do this in blue. 2 is the same as 5. 2 is on the upper left, 5 is on the upper left. They're corresponding angles. So that's the corresponding angle theorem. By the corresponding angle theorem. Okay, now let's do our substitution here. So this whole 3, 4, and 5 together, measure of angle 3 plus measure of angle 4 plus measure of angle 5 is 180 degrees. Right? Actually, we already said that. I'm repeating myself. Stop repeating yourself. Okay, we said that up here. We started with that by the measure of a straight angle. So let's do direct substitution. Let's do 4 and change 4 into 1. And let's do 2. Substitute that for angle 5. So change the 5 to 2. Okay. In this case, then, by substitution, the measure of angle 3 plus the measure of angle 4 changed for 1, plus the measure of angle 5 changed for 2, equals 180. And that's what we were trying to prove, that 1, 2, and 3 add to 180 degrees. Okay, so that's it.